Hi guys, hope all of us are fine. My name is Ernest. I'd like to welcome each and every one of us to my channel of Ernest Sciences and Mathematics TV channel. Today we are going to look at one of the aspects of organic synthesis, and that is the synthesis of alcohol. In one of our videos, of course, which was forming part one of our alcohol synthesis, we had looked at one of the ways in which we can be able to achieve an alcohol as a product. And this one, of course, entails the reaction between what we refer to as a ketone and of course and this specific reagent that we are given for the first step for Grignard's reagent, and I'm going to give that one to represent a carbon ion from that specific reagent. And then the we had said that we are going to also have what we refer to as hydronium ion that is going to be represented as that. And this one, of course, resulted in the formation of this specific class of organic compound that we had referred to as an alcohol. And in our discussion, we had given the reaction mechanism that is going to be, of course, entailing this specific general case for alcohol synthesis. And this, of course, had an emphasis on the use of the carbonyl compounds to try and come up with the product of alcohol. Now, for today's discussion, we're going to use a different reagent. And of course, this is going to, of course, entail a different class of organic compound that is going to be esters, or what we refer to as acid chlorides. Now in this case, of course, given the general illustration for these two classes of organic compounds, and specifically if we are trying to talk about the concept of acid chlorides, these are going to refer to as organic compounds that of course are reactive derivatives of carbonyl or rather carboxylic acids. And we had said that we can be able to have a general illustration for this class of organic compounds for, of course, esters being represented as such. And for the acid chlorides, we're going to have this one being represented as such for the general formula. So therefore, these are going to form our reagents in this particular discussion for the formation of alcohols from esters and acid chlorides. So in my case, I'm going to use an example of an ester. That is going to, of course, result in the formation of this. So I can be able to give a general example for this using this particular ester for that particular case. And just have this one as this. So therefore, in this case, I'm going to use also the first step for this carbon ion, and then for step 2, I'm going to have this one hydronium ion being part of the second step. This is, of course, going to take place in the addition reaction and, of course, protonation that we had seen in our first synthesis of alcohols under the use of carbonyl compounds in general, where we had considered, of course, formaldehyde as an aldehyde and other categories of aldehydes, and, of course, ketones. Now, in this case, I'm going to use this, and this is going to result in the formation of an alcohol. Of course, I can represent that one as this one, respectively. So, therefore, if I have that one represented as that is going to form an alcohol. But in addition to that, we're going to see that in our reaction mechanism, this is going to act as a leaving group that is going to combine with, of course, a proton and result in the formation of that specific product in addition to the alcohol that we're going to see here. So I'm going to illustrate this one using a reaction mechanism that is going to assist us, of course, appreciate the various processes that are going to be experienced, which are going to lead to the formation of a final product. And in essence, I've mentioned the concept of addition and, of course, of protonation. And of course, apart from that, we're going to see that there's an addition, a subsequent addition reaction that is going to take place after elimination of this specific group. And therefore, we're going to also to have what we call a protonation as the last stage that is going to result in the formation of that specific product. Now, from the illustration I've given on the board, of course, this is going to assist us try to mark up or to mark out which various stages this specific process of alcohol synthesis is undergoing through. And for the first one, of course, we had looked at a similar example for the first case for alcohol synthesis from the first example we had given in our video. But I mentioned that this is going to undergo various steps, which of course include addition. The subsequent step is going to be elimination, and this is going to be followed by an addition process, and of course course, lastly, we're going to have what we refer to as protonation, which is going to form a last bit of those stages for the formation of that. Now, in trying to illustrate the reaction mechanism that is going to, of course, result in this particular formation of alcohol, we're going to have that radical group. Just going to illustrate. This is a carbon ion from the, of course, what we had referred to as a Grignard reagent that is going to attack this carbonyl carbon at this specific point, and this is going to, of course, lead to the movement of electron to this specific point. This is going to form a formal charge of negative at this specific point, and therefore this is going to result in the subsequent movement of electron to that specific point, and specifically illustrate this one, of course. And this is going to act as a living group, of course, which is going to move out. The OR prime prime is going to move out and forming that specific group, and therefore this is going to entail the concept of elimination. And the subsequent R prime from this specific point, as I've illustrated for this, of course, I'm going to have this one as R prime. The subsequent from this specific carbon ion is going to attack this specific point, and of course this is going to move to this O group, and this is going to form a subsequent form of charge of O negative at that specific point. And this, of course, for protonation, which is the last bit of it as we had given. Therefore, this is going to pick a proton from the hydronium ion, and therefore this is, of course, is going to result in the formation. Of course, I presume that we have discussed various videos on this, how this hydronium ion is going to react with this O group, and this, of course, is going to lead to the formation of an alcohol as a product at this specific point. Now, apart from this, of course, as we have mentioned in our earlier discussions, we are going to see other, of course, examples which are going to entail the use of different reagents, apart from the carbonic compounds like the esters, and of course the acid chlorides and other compound like aldehydes and ketones that we have looked into in our first videos on alcohol synthesis. Now, catch us in our next video where we're going to look at the formation of an alcohol, perhaps using one of the reagents, which is an heterocyclic compound that I've mentioned in one of our videos, which is a three-member ring, of course, that is containing the oxygen atom. So that is it for now, guys. I hope that we have understood how we can be able to achieve alcohol using this specific reagent for esters or acid chlorides, which of course are going to form or rather undergo the similar reaction mechanism in this specific case as I've illustrated for these two specific compounds of course an ester and the acid chloride respectively. So that is it for now, guys. Bye. God bless you. Catch us in our next video.